Hey YouTube and welcome back to bneegames. Today we'll be continuing with our series on solving the Sudoku Puzzle Hunt, and I just want to thank everyone who's still been watching the videos. We're now up to part 7 and getting close to the home stretch. If anyone still hasn't tried the Puzzle Hunt yet, I strongly recommend you do so, and the link for that can be found in the description below. Now let's get back to the Puzzle Hunt. Last time on the channel we were able to solve schismatic nonominos, and we have the safe solution grid here. And once again I've added the circles for the cells that we're going to need to use in our next puzzle. Now we've only got 3 puzzles left, and it's quite clear at this point which one is next. With not enough circle clues for hypocrisy, we can just look at hostile killer and forged letters as our 2 options. And we've previously deduced that that in forged letters, the letters D and A represent the numbers 1 and 2 in some order. Now this 2 clue in this circle over here matches up with the E in this clue, which we know can't be. So forged letters is not going to be the next puzzle for us to solve, and so we're up to hostile killer. So we'll open that up in a new tab, and this time I will try and colour the cages in as per the original document. I'm sorry about my colouring of the schismatic nonominos puzzle. Let's make these blue, orange and red, and we'll add in those circled cells. So 3, 5, 8 and 2, 9, 8, 1, 9, 6, 8. Alright, I think that's all of them. And let's make sure we've got the rules, which should come up now. So we have normal Sudoku rules apply. In addition, each shaded region represents a killer cage that must sum to the value in its corner and contains no repeated digits. In addition, each diagonal must contain the digits 1 to 9. Okay. So, now that we have these digits here, there's a couple of ways where we can start this puzzle. We can start with looking at this 27 cage up the top here. So, we've already got a 5, so we now need to make 22 using these 3 cells. And there's actually only one possible way to do that, and that's with 6, 7 and 9. So let's put those options in. Obviously this middle one can't be a 9 due to this 9 down here, but we get a 6, 7, 9 triple along there. Now this 17 cage, which we've discussed before in a previous video, has 2 different ways that you can make 17 in 5 cells. Both of them require a 1, 2 and 3, and the other option is either a 4 and a 7 or a 5 and a 6. But either way, there's no 8 and 9 in this 17 cage. I suppose we could leave the 1, 2s and 3s in the corner of those cells, but yeah, either a 4 and a 7 or a 5 and a 6 is going to be the remaining digits in that cross shape. Now the 8 and 9 that we have along this diagonal is also going to be quite helpful because we can't repeat digits along the diagonal. So we now know that there's no 8 and 9 in the middle red shape, there's no 8 and 9 along this diagonal, and so we're going to get an 8-9 pair along this diagonal. To keep track, I'm going to leave that 4, 5, 6, 7, so it's going to be either a 4-7 pair or a 5-6 pair on this other diagonal, whichever one's not in the red shape. Alright, the next thing we can do is work out where does an 8 go in this column. So obviously this 8 has ruled out this cell, that 8's ruled out that cell. We already know that there's no 8 in the red shape, and this 6, 7, 9 triple up here shows us that we have no 8 in the blue shape. So we're going to get a single 8 there. And with this we can now place another 8 in the grid. So where does an 8 go in box 1? So an 8, this 8 rules out those 3 cells, the top 8 rules out those 3, and this 8 has ruled out this column, and the diagonal 8 has ruled out that cell. So we get an 8 over here. Now, there's probably a couple of other things that we can try to see and get some of the options in some of these smaller cells, smaller cages. In fact, another thing we could do is look at where can we put a 9 in this top cage. So we already have an 8, or top box I should say. We already have an 8-9 pair along the diagonal, so there's no 9s in either of those two cells. This 6-7-9 triple rules out a 9 from those two cells, and this 9 here has ruled out those two cells. So we can put a 9 up here. Okay, so there we go, we have a couple of digits now that we've placed into the grid. But the next thing to do is to look at this 26 cage up here. So we already have a 3 and an 8. That gives us 11 out of the 26, and we need to work out what other 4 digits we can place in this cage. Well, surprisingly, this is actually quite restricted. There's only one set of digits that you can place in these 4 cells that'll add up with the 3 and an 8 to 26, and that's 1, 2, 5, and 7. So we already can rule out a 7 from this cell here because of this 6-7-9 triple. We can also rule out a 2 due to that cell there. I should also remove the 2 along the diagonal. We can keep track of that for later. Okay, now for the other cells, we are going to still need a 4, a 6, and whatever cell this is. Okay. Now, the other thing that we can note is that we have a hidden kind of quadruple in box 2. So we still need the numbers 1, 2, 3, and 4 in these 4 cells. The 3 can't go up the top. And we can have a look at this box, this cage here. Okay, so we have a 9, we need to get to 17, and this cell can only be a 1, 2, 3, or 4. Well, if it was a 4, we would then be at 13 and we would need a 4 here, which is impossible. So that one actually can't be a 4. And we can also now look at, so if it was a 1, if we had 1 and 9, we would need a 7 here. If we had a 2 and 9, we would need a 6. And if we had a 3 and 9, we would need a 5. So this cell here is only 5, 6, or 7. Okay. Now, what's the next thing that we need to do? You can take a 5 out from that cell. Take a 1 out from that cell as well, due to this 1 down here. Alright, so we need 1, 2, 4, 6, and 7 along this top row. So 1, 2, 4, 6, 7. And we'll include those there as well, but obviously this one can't be a 2 due to this diagonal. Alright, so you should look at this cell a bit more closely. So this cell's quite powerful in the sense that it looks at all the cells in this yellow cage. As such, we can't really put any of 1, 2, 5 or 7 in that top cell, because then we'd have nowhere to place those digits in the yellow cage. So you can get rid of 1, 2 and 7 from that cell and left with a 4 and a 6. Okay. The next thing we can probably do is work out okay, well, we can look at this row here, and where can a 3 go in that row? Well, it's going to appear in one of those two cells. That's not that helpful yet to begin with, but I'm sure we can come back to that later. This 21 cage is probably going to be quite restricted, particularly because we can't put an 8 in there. In fact, where can we put an 8 in this box? It can't go in any of those 3 cells, can't go in any of those cells, and it can't go in this cell because it's in the same yellow cage. So one of those is going to be an 8. Similarly, we can lock an 8 to one of these cells down in this box. And I'm sorry, it's been a while since I've had to solve this puzzle, so I'll have to just try and remember what the next step is. I think the next step is still going to be at the top here, maybe looking at the rest of this row. So with the 6, 7, 9 triple, we also have 2 and 8 already in the row, so we still need 1, 3, 4 and 5. So this can't be a 1 due to that cell down there. So this can be a 1, 3, 4 or 5, and that one can also be 1, 3, 4 or 5. The next thing might be to look at this 10 cage down here. I feel like that might be restricted as well. So this can't be a 1 or a 2 along because of the diagonal. It can't be an 8 or a 9, so it can be 3, 4, 5, 6 or 7. I feel like we're probably going to be able to restrict that further, but we'll see what we can do. Okay, I suppose the question now becomes, where can you place a 2 in this column? Well, it can't go here. We've already worked out that then you wouldn't be able to place a digit in this cell and make it add up to 17. It can't go here because of the diagonal, and we already have this 8, 1 and 9 here. So the 2 is going to go either in this yellow cage up the top, or in one of those 2 cells. Either way, this cell over here sees all 3 of those options. So this cell can't be a 2. fact, I think something else we're going to be able to see is that this cell here and this cell are probably going to have the same value. This can't be a 3, so this is a 4 or a 5. 1, 5, 4, 5. Still can't see how I was meant to restrict that further, but I think there is something along this column. Might have to come back to that. Okay, so where can a 1 go along this diagonal? Well, it's either, so it can't be in any of those 3 cells, it can't be in our 8, 9 pair, and it can't be in the 2. So it's either going to be the middle of this red shape, or it's going to be in box 3. Now, if this is a 1, let's just put a 1 here, what can go here? Well, we'd have to take out a 1. There'd be no way for us to use a 2, because then we'd have 1 and 3, 1 and 2 make 3, and we'd need to place a 10 in that cell there, which is impossible. 1 and 3 would make 4, we'd need a 9 in that cell, which we've worked out would be impossible, so we'd need a 1 and a 4. That would give us 5, and we'd need an 8 in that cell, which is impossible because of this 8 down here. So this cell is never going to be able to be a 1. That leaves us both of those cells as the 2 options for 1s along that diagonal. Now, when you see something like this, the thing that I'm usually drawn to is to then try and see what cells see both of those. And we have this cell here. I don't know if that is going to be that helpful, ruling out a 1 from that cell. But either way, this cell can't be a 1. So this 21 cage is going to need a 9 in it, because we can't have an 8. And I think the only way that you're going to be able to make this 21 cage work is going to be, I think it's going to be 5, 7, and 9. If you can't have an 8, yeah, if you need a 9 and you can't use an 8, I think you're left with 5, 7, and 9 as the only option for that combination. You can't use a 9 and a 6 because then you'd need another 6. And you can't use anything, you can't use 3 digits smaller than a 9. You'd have to use 5, 6, and 7, which wouldn't get you enough. So I think that's going to be the 5, 7, 9, a 5, 7, 9 triple down there. And that's going to help us work out, because where can we place a 6 in this column? Well, it can't go in any of these 3 cells, there's already a 6 in the box. It can't go in this triple, and it can't be the 8 or the 2, so we're going to get given a 6 that goes there. We can now rule out a 6 from that cell up in the diagonal. Okay, and we can look at what else can go in this cell. We need 1, 3, 4, 5, and 7. 1, 3, 4, 5, and 7. Alright, and we've already ruled out a 1 from this cell because we found that contradiction here. Okay. Now, the other thing that we can rule out is we already have shown that the 3 has to be in one of those two cells. We can take out a 3 from both of those. I'm left with this, so 4, 5 and 7 in this cell here. Now, does that restrict this cell? Probably not enough for us to use at the moment. I suppose the question is, can this cell ever be a 3? If this is a 3, we need these two cells to add up to 10. But we can't use 9 and 1 because of that 9 there. We can't use 8 and 2 because of this 8 here. We can't use 7 and 3 because would have already used a 3 here. And we can't use 6 and 4 because of this 6 down there. And we can't use 2 5s. So I think we're going to be able to show that this cell can never be a 3. And that's going to give us a 1, 2, 4 triple in this top box. That's going to force this cell down here to become a 3. We get 3 and 9 makes 12, and that's going to force a 5 to be in that cell. Alright, we get rid of 5 here. That's going to give us a bit of success, because now we're going to be able to place a 4 in this cell and a 6 up there. Okay, so we can now take a 6 out from the diagonal, and this now shows us that the 5 and 6 are going to have to be in the red shape. So we can take a 5 here, so we know that that's now going to be a 4, 7 pair. And let's get rid of the corner marks. This is going to be 1, 2, 3, 5 and 6 in some order. We can take away the 5 from the middle because of that 5 up here. We can get rid of a 2 and a 6 from this cell because of the diagonals. Alright, and I think that might have been the breakthrough that we kind of needed. Okay, so now this one can't be a 5. And so we can take away 4 and 5 from that one down there. Down left with 3, 6 and 7. Okay. So we've got we need 2, 3, 6 and 7 in this column. Okay. Well, can either of these ever be a 7, I suppose, is the question. If this is a 7, you're going to need the other two cells to be 2 and 1. Definitely this cell can't be a 2 or a 1, because we've got a 2 here and a 1 here. So this cell can never be a 7. I don't think that's ruled out a 7 from this cell though, because you can place a 2 here and a 1 here. Actually, that is actually going to cause a problem because of this 2, 7 option up the top. So if you placed a 7 here, because the 1 can't go in this cell because of the 1 here, you'd have to place the 2 there. If you place a 2 and a 7, you then have no options for this cell up the top. So that one's also not going to be a 7. And actually now we've restricted where the 7s can go in this column to those two cells, both of which once again see this 7 here, or this cell here. So if this cell was a 7, there'd now be nowhere to place a 7 in column 3 of the grid. So this cell is going to have to be a 1. That's going to make that cell a 5. Can't have a 1 or a 5 now. We've now got a 2, 7 pair in this top box. So we're going to get a 1 here. That's going to get rid of a 1 in both of those options. Okay. And now we've blocked 5 into the bottom of the bottom row of this box. In fact, the 4 and 5 here we can just take out. So we're going to have a 1, 3 pair. We can get rid of the 1 from up here as well. Okay. And now we've put a lot more digits into the top third of this puzzle, and definitely most of these cells are quite restricted now. Okay, now I feel like we can keep looking at this diagonal. So where can a 6 go now on this diagonal? Well, it's going to have to be in this cell or this cell. That's not as restricted as I was hoping, but at least that's going to be hopefully helpful later. Okay. Now, what can go in this cell? So let's just go through the options with both this, if this cell was a 6 with each of those options, and if this cell was a 3 with each of those options. So if this was a 6, it could go with a 2. You'd need a 2 in that cell, which isn't possible because then you'd have a repeating 2 in the cage. So you could have a 6 with a 3, and this could become a 1. And we can't have 2 6s in the grid. So we've only got one option there, 3, 6 and 1. Let's try with this cell being a 3. Well, once again we'd have 3, 6, and that would have to be a 1. We can't have 2 3s, but we could have a 3 and a 2, and that would make that cell a 5. So that cell is quite restricted as well. Okay. I suppose maybe we should also now look along this diagonal. So we've got a 4, 7 pair along the diagonal. We've also got 5, 6, 8 and 9 already taken, so we just need a 1, 2 and 3. And this one down here can't be a 1. And that one can't be a 2. In fact, now we get a 1, 3 pair along the diagonal, so that's going to force this bottom one to be a 2. Okay, now we might have a bit of a restriction on this 30 cage, because this 2 sees all of the cells in this 30 cage. But I can't remember all of the combinations to make 30, so I might have to come back to that. Right, 8, 2 and 6, 5, 7, 9, triple here. We need 1, 3 and 4. This bottom one can't be a 1. Okay, we get a 1, 3, 4 triple with 2, 6 and 8, 5, 7, 9. This one can't be the 9. Okay, that's going to force a 9 into this box, into this yellow cage. So we're going to have a 6 and a 9 in 2 out of the 6 cells. That's going to be 15. So then we're going to need 15 in the remaining 4 cells. And I don't think you're going to be able to use an 8 to do that, because you'd need 8 and then 7 in 3 cells, which would only be 1, 2 and 4, and we can't use a 2. So I think we're going to be able to say that this 8 can't be in the same cage as the 6 and the 9, because then we would definitely have run into a bit of trouble. So that cell is going to be an 8. This one here, I can tidy up there, that can't be a 1. I think can tidy up further. So this cell can't be a 5 because of this 5 here. We know there's a 5 in the red shape, and we know it can't be in either any of those 3 cells, so it's going to be in either one of those. That's going to exclude a 5 from this cell here, and so that's going to force a 5 down here. Okay. Now, we're going to need a 2 in one of these 3 cells. And I think we're going to be able to say, so yeah, it can't go in this cell here. So in this 18 cage, if we placed a 2 here, we'd go with the 8, that would make 10. And we'd need to place 8 here, which we obviously can't do just by normal Sudoku, let alone because of the killer cage. Okay, so actually maybe we can also look at this, these 2 cells. So these 2 cells need to add up to 10. And so the way to do that is 1 and 9, 2 and 8, 3 and 7, or 4 and 6. Well, a 9 sees both of them, so we can't have the 1-9 pair. We've already used an 8, so we can't use another 2 and an 8. So we're going to be left with either 3 and 7 or 4 and 6. Okay. And we get a 2 up here somewhere. Alright, is there anything I'm missing along this diagonal? We still need so we've got I think we must have been able to tidy this up earlier and I must have missed it. But where can a 1 go along this upsloping diagonal? Well, it was here or here, which we'd shown earlier, but this 1-3 pair which we got took away the 1 from this option here. So we can now place that 1 in the center cell, place a 3 down here. It's going to give us a 4 and a 1. We can take away 1 from the other cells here. Alright, so we still need a 3 in this diagonal. It's going to be in one of those 2 cells. The 6, and then 4, 5, or 7. It's going to be the other one, yeah, along that diagonal. Okay. This 1 here has actually forced this cell to become a 5, which means neither of these can be a 6 anymore. So that's going to become a 3 there and a 2 there. You get rid of the 2 and the 3. That's going to make that one a 7 and that one the 6. So we can now rule out a 6 from those 2 cells. It's going to give us a 2 here, a 4. Alright. Now this 6, now we know the 6 is locked into this column of the red shape. That's going to force that one to become a 7. We can take out a 7 there. We get a 6-9 pair now instead of the triple. This 4 has ruled out 4 from those 2. We get a, and this 7 is also going to give us that one as the 4. Okay. We still needed a 6 along that diagonal. Well, that has to go here now. And so that must be a 5 or a 7, because that's the last pair that we have along that diagonal. Alright, we're getting there. So, if this was a 4 and that was a 5, that would make 9. We would need a 4 in that cell, which we can't do. So that's going to have to be the 7. 4 and 7 make 11. This one's going to be the 2. That's going to make that one a 5. We can now rule out 5s here. Alright, so we have 6, 3, and 4. That's 10, 13. And we have 7 and 9. So that's going to make 29. This is going to have to be a 1. Makes that a 3, that a 1. We can now finish this 33 clue. So we've got 5, 3, 2, that's 10, 18, 27. We're going to need a 6. Okay, this can't be a 6 anymore. And in fact, we already knew this can't be a 7 because of the 7-9 pair. So this is a 3 or a 4. That means that one must be the 6 or a 7. And that one's also going to have to be a 3 or a 4 to finish that column. Okay, now this 6 rules out that 6 ruled out a 6 from that part of the red shape. So we can place a 6 down here. This 2 actually forces that one to become a 3. So now we get a 2, 5 pair. Alright, 4, 7, 8, and 9. I think those are all still possible here. Might look at this row down here. What do I still need? 1, 2, 3, 5, 7, and 8. So this is going to be, oh, this can't be a 3 or an 8 because of they're already in the box. So those two are going to become a 3, 8 pair, and actually they're resolved by that 3. So there's an 8, there's a 3. That's going to give us the resolution of the 9, 8 pair, which is going to resolve the 6, 9 pair. In fact, this 4 also resolved the 4, 7 pair. That's going to force that one to become a 6. It's going to have to become a 4. It becomes a 3. And we're nearly there. Alright, it can't be a 4 or an 8 anymore. We've got a 7, 9 pair there. So, need a 1, 2, well this 5 actually, resolve that, 2, 5, we go 1, 2, now we should be able to finish these columns. So that one needs a 7, this one needs a 1, we get 1, 9 and 7 makes 17, we need 2 more to fill out this cage. This 7 is actually going to resolve our 9, 7 pair down the bottom here. And we're nearly there. In fact, this 5 up here already resolved that 7, 5 pair, which we actually could have done from that diagonal as well. Alright, that 7 makes that one a 9, 7, 9. Alright, this we need a 4 and a 7. It's going to be 4, so that's the 4, that's the 7. Alright, 9 and 4 make 13. We need 8 more, which we can place there. That's going to leave that one to be a 3. Alright, we need a 2, 2 there. And what else do we need? This is going to need to be a 4 and a 9, I think. And the 9 here resolves that. So 4, 9, and I think the last cell we have here is a 4. There we go, check. Looks good to me. Alright, that one definitely took a bit longer. Sorry that I was a bit rusty on that one. We will once again use a snipping tool to grab a copy of our solution grid, and we will add that to our PowerPoint presentation. Hopefully that's working now. Alright. Get rid of those title boxes again, shrink it down a little bit. Okay, we need to update our title our table again. So this time it was hostile killer is number 7, and we can go back to our document grid to work out where the hashed cell was. It was up here. Alright, so going back to our solution down the bottom here, it was that 5. So we can add 5 to our table. We'll save our asterisk cells for when we need them, which hopefully won't be too far away. And there we have it. There was the solution to hostile killer. Thanks again for watching the solve of this Sudoku. Hope you enjoyed it, and stay subscribed so that you can find out when our next video will be. Thanks.